Hello, my name is Charlie. Recently, I came across this really interesting math problem. So, let's talk about it. So, we have a triangle ABC, and it is an acute triangle with the side lengths of AB, which is x squared, BC, which is x plus 3, and AC, which is x squared plus 1. And we are told that AC is the longest side. So, what makes this problem particularly tricky is that we have four constraints that we need to satisfy. The first is that all of our side lengths must be positive. The second one is that AC must be the longest side. The third one is that this triangle must follow the triangle inequality. And finally, this triangle must be acute. So let's get started. So the first constraint is that all of the side lengths must be positive. Well, AB and AC are positive guaranteed, but BC has to be positive. So therefore, x must be greater than -3. Okay, so moving on. Our next constraint is that AC must be the longest side. So AC is already longer than AB. So let's make x squared plus 1 greater than x plus 3. We can now subtract x and 3 to both sides. So x squared minus x minus 2 is greater than 0. And now let's factor this. So x, there you go. We're going to subtract 2 and add 1. And this must be greater than 0. So, this gives us that x is greater than 2 and x is greater than -1. And this implies that x is greater than 2. And notice that we have two ways that we could do this. We could do positive, positive, which is what we just did, or we could also do negative, negative. So to do this, x must be less than 2, and x must be less than -1. And basically, this implies that x must be less than -1. And notice that x must be greater than -3. So we could just apply this to what we have. So that will give us x is greater than 2, or x is between -3 and -1. And let's box this up. There we go. So next, our triangle must satisfy the triangle inequality. So let's write down triangle inequality. Inequality. So basically, the triangle inequality comes in two parts. The first one is that one side length must be less than the sum of the other two side lengths. And the other part is that the same side length must be greater than the absolute value of the difference of the other two side lengths. So let's pick a side. Let's say that we want it to be our longest side. So x squared plus 1. So this must be less than the sum of the other two sides. So x squared plus x plus 3. And yeah, so let's subtract x squared to both sides. So that'll give us x is going to be greater than, and let's subtract 3 to both sides. So that'll be x is greater than -2. So let's take what we found and apply it to what we had earlier. So our first statement does not change. X is still greater than 2. Or our second statement does change because -2 is a tighter lower bound than -3 and -1. So -2 is less than x and -1 is greater than x. So let's box this up. Okay, so now let's do the second part of the triangle inequality. So the same side must be greater than the absolute value of the difference of the other two sides. So x squared plus 1 is going to be greater than the absolute value of x squared minus x minus 3. Now, we want to get rid of this absolute value. So let's go to the side a bit. So let's say that we have absolute value of, let's say, z. And this is going to be less than a positive integer, let's say k. And k must be greater than 0. Now, how is this possible? Well, z, it could just be, I don't know, less than k. And z cannot be less than negative k. Because if z is a very negative number, then since it's the absolute value of z, then it will be greater than k. So let's apply what we just got to what we had here earlier. So this will give us negative x squared minus 1 is going to be less than x squared minus x minus 3. And x squared minus x minus 3 is less than x squared plus 1. Okay, so let's simplify it out. So let's first do the right side. So subtract x squared to both sides, add x squared, add x. So x must be greater than negative 4. And notice how this is inconsequential, because 2 is a tighter lower bound than negative 4, and negative 2 is also a tighter lower bound than negative 4. Now let's simplify our left side. So we could add x squared to both sides, so 2x squared minus x, and we could add 1 to both sides too, so minus 2. This must be greater than 0. So now let's complete the square. So parentheses, square root of 2x minus 1 over, well, we need a square root of 2 to cancel with the square root of 2 in the numerator. And then that will give us 2x, so that means that we need to divide it by 2, so that we just have our just negative x squared minus 2. But notice that we added 1 over 2 squared to 2, all squared, so that means that we need to now subtract that, and that happens to be 1/8. And all this is greater than 0. So we could just move negative 17 over 8 to the other side by adding 17 over 8 to both sides. So that will give us 17 over 8 is going to be less than, parentheses, square root of 2x minus 1 over 2 square root of 2, all squared. So now we could take the square root of both sides. Okay, and there we go. And notice that when you take the square root of a square, it's basically just the absolute value of what's inside. So we could just do square root of 17 over, and we could simplify square root of 8. That would just be 2 square root of 2. And this is less than the absolute value of square root of 2x minus 1 over 2 square root of 2. Now we can move to the, now we could just move to the right a bit. So now we have square root of z, and this is going to be greater than a positive value k, and where k is greater than 0. So there are 2 ways that this could happen. So one is just if z is just greater than k, or z could be less than of negative k. So yeah, let's take what we got here and apply it to what we had earlier. So there are 2 ways. So square root of 17 over 2 square root of 2 could just be less than square root of 2x minus 1 over 2 square root of 2. And another thing is, or it could just be negative square root of 17 over 2 square root of 2 could just be greater than square root of 2x minus 1 over 2 square root of 2. Now, we could simplify both of these. So, what we could do is divide by square root of 2 on both sides. And then after that, we could just add our 1 over 4 to the other side. So, x is going to be greater than, common denominator is going to be 4. And then we add 1 over 4 to both sides. So that's just going to be 1 plus square root of 17 over 4. And let's do this one now. Once again, we divide across by square root of 2. So, and then after that, we add 1 over 4 to both sides. So that will give us x is going to be less than, common denominator is 4, 1 minus square root of 17. And I don't think that we're in school, so we could use our super duper, like opposite Polish notation calculator, IHP48. Let's get rid of everything, and yeah. So we have 1 square root of 17. Add these together, and we divide this by 4. So it's going to be approximately 1.3, and we could do the same. 1 enters, 17 square root, subtract these, and then we can divide this by 4. So, we got our estimated values, so this would just be, wait, my squiggle line, that was not a squiggle line, this is a squiggle line. That's just going to be an estimated value of 1.3, and this is just going to be estimated value of negative 0.8. Okay, cool. So, we got this now. Let's box it up. Oh, that was not the best box I've ever done, but that's fine. So now we have our values that we got from our triangle inequality, and we also, yeah. So, we could think of it like how we are wearing a shirt and a hat. So, we have, let's say like a blue shirt and a blue hat. And then we also have a red shirt and a red hat. Notice how there are 4 different combinations of things that we could wear. So yeah, let's switch our colors. Let's say that we want this color. Yeah. So we got, first off, we got our blue shirt and a blue hat. So, and let's make sure that we're zoomed in by 100%. X must be greater than 2, and our blue hat, which is just going to be x is greater than 1.3. And what does this imply? Well, this implies that x is greater than 2. Because if x is greater than 2, that automatically satisfies that x must be greater than 1.3. Okay, so how about our blue shirt and our red hat? This is going to be our second possibility. So, our blue shirt is going to be x must be greater than 2, and our red hat is x, it must be less than negative 0.8. And this implies that, it doesn't imply anything because it is not possible. Impossible. Because 2 is already bigger than negative 0.8. Okay, so moving on. How about our red shirt, which is this right here? So, x must be in between negative 2 and negative 1. So, negative 2 is less than x, and negative 1 is greater than x. And our blue hat, which is x is greater than 1.3. And once again, this is impossible. Because, let's rewrite that. Impossible. And this is because 1.3 is already greater than negative 1. Okay, so this is our last possibility. It is our red shirt and red hat. So our red shirt is negative 2 is less than x, and x is less than negative 1. And our red hat, which is x must be less than negative 0.8, And this implies that x is, I guess, greater than -2, and x is less than -1, because -1 is a tighter bound than -0.8. So, in conclusion, we have x is greater than 2, or x is between -1 and -2. And let's box this up. Like so. Okay, let's take an orange juice break. Okay, so now that we've done the triangle inequality, we have done that all sides have to be positive, and that AC is the longest side. Now, all we have to do is that we need to impose that this triangle has to be acute. So, yeah, so our hypotenuse squared has to be less than our side length squared. So our hypotenuse is going to be x squared plus 1. And all this has to be squared, and this has to be less than the sums of our side length squared. So we have our first side length, x squared plus second side length, which is going to be x plus 3 squared. Okay, so let's expand it out, and that will give us x to the 4th plus 2x squared plus 1 must be less than x to the 4th plus x squared plus 6x plus 9. Okay, so we can subtract x to the 4th from both sides. We could also subtract x squared to both sides. And we could just subtract 6x and 9 to both sides. So that will give us x squared minus 6x minus 8. And this must be less than 0. So now let's complete the square. So x, and we also need x minus 3, and that will give us x squared minus 6x. But notice that -3 times -3 is 9, so we added 9. So now we need to subtract 9. But notice that we also need to subtract 8, so therefore we need to subtract 17. And this is going to be less than 0. So now let's add 17 to both sides. So x minus 3 squared is going to be less than 17. Now we could take the square root of both sides. Square root. And once again, when you square root a square, it's like taking the absolute value of what's inside. So we have the absolute value of x minus 3, and this must be less than square root of 17. Okay, so we're almost done, and we could just take what we did before up here and do the same thing. So this would just be negative square root of 17 is going to be less than x minus 3, and square root of 17 is going to be greater than x minus 3. And that's what we did up here. Okay. So, now we could add 3 to the right side and also do it to the left side too. So, that will give us x will be less than 3 plus square root of 17 and be greater than 3 minus square root of 17. Now we're going to pull out our super duper Polish notation cool calculator, and looks like that it crashed, but that's fine. Let's just reboot it and hope that it works this time. Okay, there we go. It works. So we have to get 3 square root of 17, subtract. So that's going to be our 3 minus square root of 17. And now let's do the same for our right, except that this time it's going to be addition. So 3, enter, 17, square root, add. So now we have our estimated values of negative 0, not negative 0, negative 1.1 and 7.1. So we can just throw these in. So negative 1.1 will be less than x, and x will be less than 7.1. Now, we could get what we have here, right here, and combine that with what we had here. Let me just box it again, because why not? And yeah, so we have x is greater than 2, and we have what we have here, so negative 1.1 is less than x, and x is less than 7.1. If we go back up here, x is in between negative 2 and negative 1, so x is between negative 2 and negative 1, and we just have what we have here, so negative 1.1 less than x, and that is less, and x is less than 7.1. And or so now, yeah, so what does this tell us right up here? Well, 2 is a tighter lower bound than negative 1.1, so 2 must be less than x, and x must be less than 7.1. And over here, what does this tell us over here? Well, this tells us that, well, negative 1.1 is a tighter lower bound than negative 2. So let's keep it. Negative 1.1 is less than x. But negative 1 is a tighter, higher bound than 7.1. So negative 1. Now, where do we get 7.1? Well, we got it from 3 plus square root of 17. And where do we get negative 1.1? Well, we got that from 3 minus square root of 17. And yeah, there we go. So this is our, well, all the possible values for x. And yeah, so this is quite a difficult problem, and I'd like to thank my geometry teacher for, I guess, challenging us. And yeah, so that is the answer, and I'm going to go type this out now.